Welcome to Careless Coder. Today a little programming video. We haven't done that in a very long time. Motherfucker! So the other day I was watching Numberphile.
I would like you to imagine, Brady, there are 100 light switches in front of you. At the moment they're all off. The first person comes along and turns them all on.
Now that person is either on speed or running from his alimony.
The second person turns every second light switch off.
And that's O.J. Simpson running from the cops.
The third person deals with every third light switch. In that they don't just turn them on or off. If they're on, they'll turn them off. And if they're off, they'll turn them on.
Professor, as engineers call it toggling.
And the fourth person deals with every fourth light switch. The fifth person deals with every fifth light switch. I suspect you have the pattern. And that continues for 100 people.
And I was like, I don't really know what the answer will be. I'm curious. Let's write a little program. This is really simple. This is entry-level programming. So I wrote up a simple program in Python. And later I also did it in C and Rust. So all the versions are in the GitHub. And it's actually a good insight question I figured when I was creating it for example, testing your intern's ability. Because you can instantly see how they structure code, because you have a logic part, the switching of the switches, and you have a printing part, and they should be two different functions. The switching can be done in a very convoluted way with branching, using an if construction or even a ternary statement, but it can also be done with bitwise logic. So it will show a bit of insight in the way that a person thinks. So let's jump in and write this up in Python, and then I will also show you the code that I've written in C and Rust. Programming! Yay!
Okay, I have my scaffolding here. For all you Python programmers on Windows, don't be a twat and write a shebang, will you? And use this format, user bin env Python 3. What it basically does is shebang tells whatever is here that needs to be started before and pass the underlying script to it. So this says get the location of Python 3 out of the environment variables and just write it here. So we have a shebang user bin Python 3. And that way on Unix you just give it execute rights and you just run the application. You do not have to put in Python 3 space myscript.py, as I have seen so many stupid, underdeveloped Windows Python developers do. You fucking morons. Alright, sorry, that was a rant. Let's analyze this. So we have 100 switches and 100 people, so we have the same number of switches as people. That makes it easy, so n equals 100. And then every person, so person 1 will switch every first switch, so he will indeed switch everything on. The second person will toggle every second switch, so it will toggle them off in this case, that is because everything is on. And I use the word toggle because toggle means doing the opposites on the switch, so if it's on it becomes off, if it's off it becomes on. So the third one will do the modulo of 3. So basically it's a modulo. It's really simple. And let's use an array. I know that most Python developers probably used a list in this case, but let's use an array because it translates really nicely to C, and Rust also has the construct of arrays and slices, so you can really see the code. And it's really good to every now and then really go deep. Go deep and enjoy that experience of actually exhausting yourself. Okay. So let's create a array. Let's not call it switches, because if I go and iterate through it, if you would use a for each, you would use the single name, so switch instead of switches, as switches are a reserved word. And when I for loop through the length of this array, I will also use the variable switch, and switch, yeah, is a reserved word, so yeah, let's use buttons. And buttons also have an on-off state. Equals, we're going to set them to 0 for the size of the number of switches / people. Now, it's always important. That's why I also like buttons. If you would do an interview question, I don't really like technical interview questions. I think they're a bit insulting. But for your interns, for example, it would be really nice to see if they grab the concept that if you create an array, that you cannot be guaranteed that it's zeroed out or in a known state. In this case, we explicitly set it to 0. If you, for example, would just malloc 100 bytes in C, you would just get a pointer to a piece of memory for 100 bytes. Now, most operating systems these days zero this out for a very valid reason, because operating systems are now multi-user. So imagine that there was a user that would have started an application with a password, and the password was on the heap. And you get a pointer on the heap and you go like, hey, that's fascinating, that's the password. Let's write that down. So that's why most operating systems these days, when you call a malloc, will call what we call calloc in C. That's a clean malloc. But I will show you that later on. But always set your arrays to a known state yourself. Because blind dates, you never know what you're going to get, right? All right, so let's iterate through the people. Now, usually I would create a function called puzzle, but yeah, for now, just iterate this, the person, and like we say, we're going deep, and we're going to manually iterate through this. Now, here is an insight question in this problem. Since we're dealing with modulos and arrays, so basically we have an array on, or a switch on index array 0. Person 0 divided by 0, because that's what a modulo is, it's a division with a remainder, is a division by 0 error. So we want to start at 1. And it's perfectly valid to start iterating at 1, just as long as you maintain that consistency in the same program file. As soon as I see a person starting from round 1, psychologically, you would assume that the rest is 1. And not 0, for example. So we're going to do from 1, and we're going to be consistent. And then we need to add 1 to it as well, because otherwise we only iterate through 99. Okay, let's do some model view controller. We already have a model. It's a very simple one. It's an array, but it's still a model. And let's have a controlling function handle this model. So let's create switch logic, and let's put the buttons into as a reference. Now in Python you don't really have to bother about, well, if it's a reference, it's just passed as a reference in this case. In C, for example, or especially in Rust, if you pass this in Rust, it will actually make a copy of this array. So you're not working on this pointer, but on a copy of that set. And as soon as you get out here, this is still 0. So when you pass variables, you beginner programmers always think, do I need to send them by reference or by value? And if you use an interpreted language, always look the manual to see how they handle these cases. So let's create a dev switch, and we put in the buttons as a variable. All right. And we're going to list through all the buttons. Button in range. As I said, we're going to go deep. We're going to do it this way, a +1, of course. Otherwise, we don't really like that. There, that's better. All right. So we said it's a modulo. So we have a modulo. A modulo of what? Well, basically, you have a button and a person. Person. So buttons. I need to pass in, by the way, my person here. I forgot buttons and person. So person. If the remainder is 0, then we know we have a multiple of that person. All right, yeah, and then we just toggle the button. And this is an inside question that I pose to our interns. In my previous job, we did a lot of systems development for order pick robots, for example. So you're really dealing with individual bits that you need to toggle on and off. And something happened around 1996. I call it left-wing influence in colleges, because stupidity started to happen. Because the majority of people that we got as interns since 1996 use a ternary statement. So basically they say, if button equals true, then false, else true. And I'm like, yeah, but an if creates a compare, and you would need a branch. You can do this branchless with a single instruction. How would you do this? And I would just let them figure this out. And it's really simple. It's bitwise operations. For some reason, bitwise operations are not taught or forgotten in the left-wing colleges since, well, 1996 really, because 80% didn't do that. You can do this in a simple instruction. The value buttons. And I also noticed this in a lot of Arduino programming with the flashing sketch, the light on and off. That you go, if it's on, then off, else no! Use a bloody frickin' XOR -1, because this is 0 based. XOR 1. An XOR 1 will toggle the bit from 1 to 0 or from 0 to 1. It's as simple as that. And I'm very disappointed that people who studied computer science don't know this, don't use this. I think it's a death sin, to be honest. Anyways, more rant over. So let's do a view function, a print grid, and let's be very simple about this. We will print the person number and the number of buttons. And we just do a 10 by 10 grid. We're not going to do what Brady did, render a nice apartment block with lights flashing on and off. Really nicely done, Brady. Awesome. Or even the professor that had a nice list of circles that light up yellow or black with the number in it. No, we're just doing a 10 by 10 grid, which shows the state of the switches. And this is cool, this model view controller, because if you, for example, want to create an XML, you just implement a new version with XML. Or if you do OOP, that is where object-oriented is really nice. You can create a factory method and just say, okay, I implement a view class XML and a view class awesome apartment building with lights. But yeah, we're just going to be very simple. So we put in the person and the buttons. Again, by reference, I don't want to copy. And we're going to be still starting from 1. We iterate, doing it the hard way. We're going to dive deep, right? And let's print my person name so I know which person is funneling my button. I need to convert that to a string because that is an integer. Alright, and we're going integer. And like I said, we're not going to use the convenience methods. We're going down deep. So we use that range. And we can use n because I have the n plus 1. Yeah. Then we print the state of the button, as simple as that. Buttons. Button -1, and this is a stupid Python thing because print automatically does a new line and comma end equals quote quote avoids that print line. I would prefer print \n if you want to print a new line, but yeah, okay, it is Python. All right, okay, so I think this is it. Last famous words. Let's give it some rights. chmod 755 switch. This is thus octal. Oh, I need to. I'm still in my Rust version. Switch pi. I will go through the Rust and the C versions after this. Not writing it out, just showing the code. chmod 755 switches. switch.py. Oh, we got an error. Button is not defined in 21. 21. Oh, it's buttons. Everybody already saw that. Okay. Oh, I forgot something. I said it's a 10 by 10 grid. So if button modulo 10, that would work in this case. Then print also an empty line. Yeah, that looks better. So let's see. The first situation, well, modulo 1 is basically everything. Would set everything to 1, so everything is 1, yeah. We saw in Brady's awesome video that the apartment building has on, off, on, off, on, off, on, off, on, off, on, yeah. Then we have the third, the fourth, and that fifth, yeah, that also matches, and all the way to 100, boom. And when I was looking at this, I still didn't really understand the maths. I will not explain it here. Watch that video of Numberphile. Only when they talked through it, I was like, oh, why didn't I see that? Maybe I didn't see it because I don't really have a value here. I know that this is 1. I know that this is 4. But yeah, it's a good video. Watch it. It's awesome. And also, I'm not the best at math. Right, so let's go quickly and show you the comparison with C. So we have the same structure of the code. I create an array of characters because 1 and 0 can be a character. And I use that Kellogg's cornflakes. That is a clean malloc, and it basically says create this many bytes, 100, and set, well, in this case, every byte, the structure is only 1 byte long. That's basically what I say. If you have a complex structure, for example, 100 bytes, so 10 times, so 1,000 bytes, this will be 1,000, this will be 10. But most operating systems, as I explained, with the reason why, actually zero it out if you call malloc. And you also see this a lot in C. You see malloc, and then a mem set with that pointer buttons, and that size set to character 0. But you don't have to. There is a function for that that does that for you. Right, and again, we iterate through all the users. It would be nice to create this in its own function. You can refactor that yourself, where you pass in the number of persons. And then we have the switch logic. The same way, we just do the XOR here. You see it really translates nicely. And printing the grid, going through this, and just printing it, and every 10th one we print a new line. This is really the way that you actually want to do this Python. Just print a new line. All right, and Rust. I love Rust. I'm getting to really love it. Here we do the same thing. Set the value of this size array to 0 for these many positions. Let's give it a nice new line here. Iterate through all the persons that we do, n+1. Call the switch logic. Here we switch them. We do the same thing with an XOR. I don't really like in Rust that if you have a single instruction, you still need to use brackets. And I know I'm a bit of a hypocrite. I say be consistent with the starting from 1. And the same is with the brackets. This is consistent. I cannot really argue against it. And hence I put them on the same line, because that's the way I would do it in C. And also the same thing with iterating through the list and printing it. So you see, if you learn C or Rust, it's really easy to learn Python. And vice versa. If you know Python really well, it will take you a shit ton of work understanding calloc and malloc and in C. Hence I would say start in C. But yeah, it translates really nicely. And I said, if you malloc, you also need to do a free. In this case, we could get away with not using it, because if you exit the application, it will free the heap anyways. But yeah, as soon as you do a malloc or calloc reserve memory, also immediately write a free when the scope is done. Then you will never forget. And this is it. This is really a nice, simple programming exercise. Hence I was like, oh, let's write this in 10 minutes and see what the outcome is and continue to watch the video.
So there you have it. we created a very nice beginner program that will tell us the answer of a riddle. And this is what computers are really good at. They are brute force machines. So when I was posed that riddle, I was like, I have no clue. This is really complex. I need to actually see it. And that's what I loved about this professor at Numberphile. He also said, like, just run through a couple of examples. People think you need to do maths in your head or on a sheet of paper. No, you can just look at them. And even after seeing it, I was like, I don't see the pattern. Maybe because I didn't print the numbers in it. It took me until almost the end of the video. I was like, oh, now I understand the mathematics behind it. So, and I'm terrible at maths. I really am terrible at maths. I'm really an applied mathematics person. So, yeah, I hope you learned something. We did some Python programming. I know that a lot of my beginner viewers really love Python, so hence Python. But we also snuck in some real languages, C and Rust. See you in the next one.